All right, welcome to WSQ number 20. Today we're going to be talking about human genetic disorders. Really three objectives for us today. We're going to talk about what are the two major causes of genetic disorders in humans. And we're going to talk about how geneticists actually trace the inheritance of traits in someone with a disorder. And we're going to talk about how genetic disorder is diagnosed and treated. So that's what we're going to jump in today. We need to start off first of all, by understanding what in the world we're talking about when we say a genetic disorder. A genetic disorder, by definition, is an abnormality. Okay, so it's an abnormal condition that a person inherits through genes or chromosomes. And this is important because it comes through genes or chromosomes. So for a genetic condition, for something to be a disorder that's genetic, it has to be something that got passed along from their parents. A condition like, for example, if you get a cold's not a genetic disorder. Okay, now you may have a genetic prevalence towards certain diseases or disorders, things like cancer, but you're not going to pass on the cold to your kids. Okay, at least not genetically. So genetic disorder, any abnormal condition that a person inherits through genes or chromosomes. There's two major causes for genetic disorders, okay, that you need to know about. The first one are changes in the DNA of the genes. This is what we talked about earlier when we talked about the three types of mutations. So this would be when you have a substitution on the basis of nucleotides. Substitution, yeah. Okay. Or if you have a deletion, this would be a second type. Or if you have an addition. Any of those three types of mutations, those are actual changes to the base sequence. So if I have, right here is just my DNA, and I had A, T, G, G, let's say. Then on the other side would be T, A, C, C. If I had any change of this, either substitution for a pair, either a deletion of a pair, or an addition of a pair, that's an example of a change in the DNA or genes. The second cause is an actual change in the structure or number of the chromosomes. So all of these are going to address with genes, those are changes in DNA genes, or chromosome, changes in the structure or number of chromosomes. Now, here's some examples. I've got actually 5. Let me add one right here. Cystic fibrosis, sickle cell anemia or disease, hemophilia, Down syndrome, and albinism, which we're going to show. I want to just show you each of these and kind of talk quickly. These are some examples, how they're different, how they're the same, what causes them. So the first one we're going to talk about and address is cystic fibrosis. Cystic fibrosis is a disease, it's a disorder in which the body produces abnormally thick mucus. So we're talking about mucus that is like way thicker than it should be. Now obviously with thick mucus, this causes problems for anything in the respiratory system. So the airway, primarily the lungs, the bronchial tubes, you have problems with this. Also can cause problems in the pancreas, can cause problems in the intestines. Okay, any place where you have small avenues where objects have to get, if that mucus it builds up and it's thick and they can't get rid of it, it can cause problems. This is caused by a recessive allele on one single chromosome, and it's a result of a mutation in bases. So it's actually a deletion of 3 bases in this particular allele, and it gives people cystic fibrosis. And ultimately, this will make it hard for people to breathe. It can lead to infections because of the mucus. It can lead to all kinds of problems, inflammation in the airway. We can see right here as it's showing in the alveoli some of the different infection, and also down here in a pancreas, what's called a mucus plug, or even in the pylorus, you can have problems where the stomach meets the large intestine. So that's an example of a genetic disorder that's caused by a mutation in a base. Second type is called sickle cell disease or sickle cell anemia. This is actually a co-dominant condition. So this is caused when a person has 2 alleles with the disease. Okay, so in the case of sickle cell disease, this affects the hemoglobin. So here's our red blood cells. Typically red blood cells, normal red blood cells, look like this. They're round in shape, and remember red blood cells are actually the protein hemoglobin is what makes up the red blood cells. Okay, and in normal red blood cells, they're round in shape. You see the hemoglobin, how they're set up. And why being in that kind of roundish shape, it allows them to carry the most oxygen. They're flexible. They can get through capillaries and squeeze into areas and allows blood to flow easily. In sickle cell, you get this kind of shape, so this would be sickle cell. In sickle cell, the hemoglobin actually forms these long chains that are not flexible. And so what happens as these red blood cells, the sickle cells, get into the bloodstream, they can actually get stuck in smaller capillaries. They can cause blood clots. They can cause pretty severe issues. The thing with sickle cell is there's usually not a lot of symptoms of the disease. It's something that will show up later on in a person's life. And like we said, this is codominant. So what happens is you can have the sickle cell. I can be a carrier of sickle cell disease and actually produce some sickle cells, but be normal. But if I have the disease, sickle cell disease, then I'll actually produce most of those hemoglobin. And if you have too much hemoglobin, it could be a real serious problem if they're sickle shaped. Third disorder we're going to talk about is called hemophilia. I've talked about this before. Hemophilia is a sex-linked disorder. It's actually caused by a recessive allele on the X chromosome. So this would be an X-linked disease. Okay. Hemophilia is a blood disorder. So what happens is there's a protein that's necessary for clotting of blood. And in hemophiliacs, they don't have that protein. So when they have any kind of injury, whether it's internal bleeding, it can be even something as simple as just regular use, that blood will not clot, won't go through the process of coagulation, which can increase all kinds of internal bleeding. So a bumping or a bruising can actually be really, really, really severe. And like we said, since it's an X linked chromosome disease, typically this hemophiliacs mothers a lot of times can be carriers. A lot of times we'll see this because it's X-linked. The males will demonstrate this a lot in hemophiliacs. And this is what drawing you can't see very well, but basically what would happen is in a normal, when you start to bleed, you'll have a platelet plug that forms that actually blocks that particular vein or artery off. In hemophiliacs, the plug never actually forms, and so you end up having just a continuous bleed. A fourth disorder that you're probably familiar with is known as Down syndrome. Down syndrome is a disorder that actually affects the 21st chromosome. We can see it right down here in this karyotype. And you'll notice that there's 1, 2, 3. It's a trisomy or a ploidy mutation. So what happened, it's caused by a recessive allele on the X chromosome. And it causes the person to be born with a third chromosome on the set of 21st chromosomes. This leads to some defects. Okay, typically people with Down syndrome have some degree of mental retardation. They can have a level of just physical appearances. This little girl right here is a Down syndrome person. Now, just so you're aware, though, at the same time, as we talk about all of these things, we need to understand there is a difference between a disorder and a difference between, I've actually had the great privilege of knowing people with Down syndrome, and they're amazingly kind and gentle people and really, really amazing people. And so we need to make sure that as we talk about these, just because they're abnormal or different from what the norm is, doesn't mean that they're not designed with a purpose. I mean, I think God brings people, especially people with Down syndrome and disorders like this, into our lives because they drastically change us. And they're wonderful people that really, really, really love to be around other people. So Down syndrome is a disease as well. And then the last one I'll talk to you about is albinism. Albinism is a disorder. It's caused by a recessive allele that literally keeps melanin from being produced. There's actually two types of albinism. But commonly, they don't have melanin production very high. And so what happens, people with albinism, like this girl we'll see here on the left and the girl on the right, very fair features, typically have no pigment in their eyes or very, very light pigment in their iris. The reason why you see this red eye production here from this girl is because there's no pigment in the back of her retina. So as the light hits the back of her eye, it reflects back. We're actually seeing the blood vessels on the retina. Where in the typical person, the pupil looks black because as the light shines through and hits the back, there's actually some pigmentation on the retina designed to absorb the light. People with albinism obviously have some risks in the sun and things like this. It's also called an autosomal recessive disease, meaning that it's a disease that affects your appearance or your phenotypes, but it usually only shows up, okay, in that's X-linked. In this case, would be in if the father's a carrier. It may only show up in an affected child when you have both recessive traits. So that's another one. So those are just a few different genetic disorders and some examples. Second thing I want to talk to you about today is the pedigrees, what a pedigree is. And this right here is a pedigree. A pedigree is a chart, okay? Think of it as a family tree that tracks the different members of your family and the traits that they have. You guys are going to be doing a pedigree next soon. And we're going to actually talk about how this actually shows up your traits. So in a pedigree, a few things you need to understand. Circles always represent female. So anytime you see a circle in a pedigree, we're talking about the female. Of course, that means that squares will represent the male member of a family. Okay. If you look at these, you can see that some of the circles and squares have different colorations. If a square or circle is completely shaded in, that means the person has that particular trait that we're talking about. If it's half shaded in, okay, like in this kind, half shaded square, this would be a carrier, okay? And if it has no shading whatsoever, this means that this person doesn't have the trait, neither is it a carrier. So in this particular example, if you looked, and I asked you the question, how many people in this family line have the trait? Well, the answer would be just one. This is the only person that has the trait. Well, if I asked you how many carriers are there, then you would count 1, 2, 3, 4, 5, 6, 7. There's 7 carriers. And how many normal people in this family? There would be a total of 7. So you actually, knowing what the pedigrees look like can actually help us understand a little bit more about what's going on in a family. There's a really good activity on phschool.com. If you go to it, CEP 3042, would totally encourage you guys to do this, which is a pedigree activity, which will help you with this. Now let's take a little example. We're going to just kind of do a little activity with this. So here is a pedigree. And what I want to show, this is the inheritance of hemophilia. Remember, hemophilia is a sex-linked disorder that comes in families. And notice here's our key. Remember, circles are going to represent females, squares are male, and if it's fully shaded in, they have the disorder, hemophilia. If it's half shaded, they have their carriers. So if we start at the top, this would be the female, this would be the male. Now, if I ask you the question, female, male, did any of them have hemophilia? Well, the male, the father, did not have hemophilia. He's empty. The mother was a carrier. Right, we can see that. And then they had how many children? When we look at their chart, each of these lines, just so you're aware, these lines represent marriage between two people, and then the branches, these would be their children right below. I didn't say that. Okay. Now, how many children did they have that were actually had hemophilia? Well, we can see they had one son, okay, that had hemophilia. They had one daughter who was a carrier as well. Okay, and they had 2 children who were normal, right? These children did not have any of the hemophilia disease. Now notice, the daughter married a husband. Here's the male, there's the female. Daughter married a husband who was not a carrier, did not have the disease. And notice they had 3 children. 2 children had normal, no change. And one of their daughters was a carrier, right? Okay, and we can see that daughter came from, married a man who's mom and dad, right? Here's mom, female, here's male. Notice that in this case, and by the way, this is this could be confusing. This is female and male, not mother and father. Female and male, what do we get? This guy had no traits. The mom was a carrier, but look what happened. The mom passed that trait down, and what happened? They had a son who was hemophiliac. And so as you look at this, pedigrees you can see are great because they help us understand better the traits of people. Last thing I'm going to talk to you about is, hey, how do we manage this? What in the world's going on? So with all this information, how do scientists and doctors and all the different people, what do they do with this? We have all these new tools that are allowing doctors to help diagnose and treat genetic disorders today. And we're in a totally different place than we were even 10, 15, 20 years ago. One thing that doctors use are called karyotypes. This is a karyotype right up here. A karyotype is basically a picture of all the chromosomes in a cell. So if we look at this picture, it would be chromosome 1, 2, 3, 4, 5, 6, all the way across, all the chromosomes. And this helps them, the doctors, have a better understanding of what they're actually looking at, what the organism, what that person looks like. They can see if there's an issue. For example, we talked about Down syndrome. They can actually see just from the karyotype whether or not that child has Down syndrome on that 21st chromosome. So let's doctors see at least the correct numbering of chromosomes and helps with genetic disorders. Now, how do they deal with the actual disorder? So maybe they get this information. How they deal with it is some of the changes that have been happening. There's modifications that can be made to the environment through medicine and diet, through education, which can help manage some of the disorders. And we're in the process now where they're starting to come up with ways to actually correct disorders through genetic treatment. So we'll talk about that in the next lesson. So you're done. You've watched it. Please make sure you summarize and answer the questions, and I will see you guys in class. Bye.